GCSE Higher Practice Paper 5B from mathstutor.biz and mathsdvds.co.uk. This video clip we're going to be looking at the question number 16 from this particular paper. That one there, question number 16. If you want to see the rest of the questions on this paper, then you'll need to get your own copy of this paper, along with the DVD that explains fully the answers to all the questions along with the marking schemes. To do that, you'll need to visit mathsdvds.co.uk or mathstutor.biz. They're two of my websites. And then buy it. I don't apologise for keep these little adverts at the beginning because, well, let's face it, I'd like you to buy one. But enjoy the freebie. Enjoy the freebie. GCSE Higher Practice Paper 5B, question number 16. We're told that PQRS is a cyclic quadrilateral. In other words, it's a four-sided shape that fits perfectly inside a circle. Each of the points are on the circumference of that circle, and not all quadrilaterals do that. Only cyclic ones. That should be a small q, really. Right. TS is a tangent at the point S, so that's right. SRQ, where's that? SRQ is 104 degrees. Tangent SRQ is isosceles. SRQ is isosceles, so that line there is meant to be the same length as that, so that angle equals that angle. Find the angle QPS, and so let's look at QPS first. QPS, find that angle in there. Now, here's something to make a mistake on. You look at the diagram and it looks like that's a diameter. And the angle subtended on a diameter is always 90 degrees. And it looks as if it might be 90 degrees. But you must not go by what diagrams look like. All diagrams are not drawn to scale. All diagrams on the exam paper are sort of badly drawn. Unless perchance you're told it's drawn to scale, then that's a different matter. So that may or may not be 90 degrees, but I can't use the reason on that, say, diameter, because it isn't contained in my information. Right, so that's the wrong way of doing it. The right way of doing it is to know that the opposite angles of a cyclic quadrilateral always add to 180. So therefore I can say that QPS equals, that's QPS, 180 minus SRQ. Put an angle sign over the top there. I didn't write down 104 straight away because this helps explain things. And so therefore it's 76. It's too big for 76 when you see the diagram, but the diagram's not drawn properly. But must give reasons, because opposite angles of cyclic quadrilateral always add up to 180 degrees. So that's found that angle, and it has set Y. Now RST, this angle here. Now that is the angle between a tangent and a chord. You can see that it's an angle between a tangent and a chord, and it equals the angle subtended by that chord in the alternate segment. Here's the chord, and there's the angle subtended by that chord. So this angle here equals that angle there. But I don't know that angle there yet. However, this is an isosceles triangle. I know that angle, so I can find it. So that's my approach. In triangle SRQ, you can do those letters in any order, SQR if you like, QSR, SRQ. In triangle SRQ, comma, SR, oh no, it says it's isosceles. I can say angle SQR equals angle RSQ. Let's just check that. SQR equals RSQ. Yes. I shall write isosceles triangle, and the word I'm going to write is given, because we're given that information, and that's a property of an isosceles triangle, which implies that the angle SQR equals 180 minus 104 divided by 2. I take 104 away from 180 and share it between those two angles. So that is 76. I don't know if that's a coincidence, that's the same as that. I think it might be. Divided by 2. And that's therefore 38 there and 38 there. Well, it isn't 76, is it? I pointed the wrong thing. I'll say it's a coincidence that those two add up to 76. Okay. The only thing I haven't included in my reasoning is that the angles of a triangle add up to 180 degrees. So I'll put that in here. Angles, triangle, sum add up to 180. Okay, we now know that's 38. So we can now write down that SQR equals 38 equals the angle we're trying to find, RST. Reason, angle between tangent and chord equals angle subtended by the chord in the alternate segment. Now you can only read that because I read it out to you as I wrote it, but I don't think it's neat enough for an exam paper, is it? So make sure you write neater than that. Okay, let's mark that. We've got a mark for the 76 and a mark for the reason because it was a cyclic quadrilateral. We've got a mark for this 38 because it was an isosceles triangle. And a mark for this 38 and the reason because the alternate angle theorem.